So this is our second question with the cosine law. We've got in triangle KMN, KM, so we can draw a triangle, not to scale. KM is 16, KN is 11, and MN is 6. So obviously that does not look to scale at all, but that's not bad. And we want to find the measure M to the nearest degree. So now with our cosine law, we have two forms of the cosine law. So if you turn back to page 492, the textbook gave us one form. We wrote in a second form because they're both on your formula sheet. The second form looks like this. Cos C, and I'll write it exactly as you have it on your formula sheet, a squared plus b squared minus c squared over 2ab. But in our question, we don't have a's, b's, and c's, so how do we do it? Again, the key component to this formula is recognizing that angles go with opposite sides. So the angle that we want to find, we would put there where the C is, and the opposite side goes there. The rest really doesn't matter because a squared plus b squared is the same as b squared plus a squared, and a times b is the same as b times a. Yes?
Isn't a squared plus b squared c squared though? So if you're minus c squared.
Only in a right angle triangle, remember? No, because that only works in a 90-degree triangle. What? It would be nice, right? Then this would just be 0. And so in our case, we want to find m. So we would write cos of m equals, the key thing in the formula is opposite the m is the 11, so this has to be minus 11 squared there. What you choose as a and what you choose as b doesn't matter. 16 squared plus 6 squared, 2 times 16 times 6. We type this whole thing into our calculator. Here, I'll do it on the screen so we can see it. (16 squared plus 6 squared minus 11 squared over 2 times 16 times 6. And we get 57 over 64. Yes? I'll come have a look at it. So if it came up as a decimal, that's fine. You could write the decimal as well. And now m, to find m, we go back to our calculator. We would go second cos inverse of that answer. And we get 27.0. It says to the nearest degree, 27 degrees. Cos is positive, right? According to the cast rule, it should be in quadrant 1 and quadrant 4. But because we're dealing with a triangle that the angles have to add up to 180 degrees, anything in quadrant 4 wouldn't make sense. So in this case, that's why the cosine law doesn't have an ambiguous case in the same way that the sine law does, because only one answer is going to make sense, and that's the 27 degrees. Part B, triangle STU. ST is 16, SU is 20, and TU is 6. Find angle T. So again, setting things up, cos of t equals, the important thing is opposite the t would be the 20 squared. The other sides don't matter the order. Once you understand how the formulas, the relationship works between them, then things become really easy. So now I'm going to come back to our calculator. Do you notice that it's exactly the same except it's a 20 instead of an 11? I'm just going to copy this. Just a little bit of cheating. And we get negative 9 over 16. Which, if you got the decimal place, that is fine as well. Now, according to the cast rule, where is cos negative? Quadrant 2 or quadrant 3. But for a triangle, quadrant 3 won't make sense. If it was in quadrant 3, it would be between 180 degrees and 270 degrees. Does that make sense? So if I have it in quadrant 3, starting here at 180 degrees, going to 270 degrees, say I have 200 degrees. It's going to be very hard if one of the angles is 200 degrees in a triangle for all three of them to add up to 180. Okay? So how do we find an angle in quadrant 2? What do we know? We know if we drew it with our reference angle, the adjacent over the hypotenuse would be 9 over 16. If you use that little triangle, you could find your reference angle. I guess I should actually label it correctly in here. It is the reference angle for t, so t with a little r. So I could say, I know that cos of my reference angle would be 9 over 16. I could go to my calculator and find my reference angle, which is 56 degrees. If my reference angle is 56 degrees, what is my actual angle in quadrant 2? Went to my calculator and I drew the triangle with the reference angle. I used SOHCAHTOA from grade 10, and I just did cos inverse of 9 over 16. Okay? And so angle T, because it would have to add up to 180, will be 124 degrees. Again, we're using the idea of a reference angle here, so we can go back and say this angle to the nearest degree would be 124 degrees. Notice when you do cos inverse, and this only works with cos inverse, of negative 9 over 16, it will give you the 124 degree angle in quadrant 2. That doesn't help you find an angle in quadrant 3 if you needed it. So again, I would recommend drawing out the triangle and finding your reference angle and using that to solve for the actual angle in the triangle. Okay, questions for practice. Try these right now. Question 5 and 7.